previous class already we have seen about your reflection of light at a curved surface. So today let us start our second chapter, chemical equations. So before starting this chemical equations, we should know some of the terms related to these chemical equations. What is the definition for the chemical equation? So let us see what is chemical equation. So chemical equation means chemical equation. So chemical equation means it is a balanced equation comprising of reactants and products. Okay, so chemical equation means it is a balanced equation comprising of reactants and products. So what is that balanced equation? Let us see one example. See here, I am taking NaOH plus HCl. When these two are reacting, okay, they will give you NaCl plus H2O. Okay, so this equation is called as chemical equation. Why? Because here NaOH and HCl, these are the two substances combining to form a new substance. So this total equation, when two substances are combining and giving you two new products, means total representation of that equation is known as chemical equation. And here we should be balanced. Balanced means number of atoms on the reactant side and the number of atoms on the product side, they should be equal. So let us see what is that reactant. See here balanced equation comprising of reactants and products. What is this reactant and what is the product? Let us understand. In this equation, the terms which are these two substances which are combining are called as reactants. So these two substances, they are combining to give new products, that is reactants. And products means the two substances which are formed from the old substances are known as products. Okay. So now let us see the definition. Reactants. So what is reactant? Reactants means the substances which are combining to form to give new products, new substances are known as reactants. So in this equation, which are the reactants? These two, NaOH and HCl. See, NaOH and HCl, when it gives rise to NaCl plus H2O, here these two are known as reactants because they are combined to give new products. Okay, now let us see what are the products. See here, NaCl and H2O are the products. So what is the definition? Let us see products. And H2O. So what is the products? You see. So product definition: substances formed after a chemical change. Are called as products. Okay. See here. Suppose let us take the same example here. NaOH plus HCl gives rise to NaCl plus H2O. Yes. In this equation, NaCl and H2O are called as products because these two substances, they are formed from NaOH and HCl. NaOH and HCl, they are called as reactants. Just now we are saying. So NaCl and H2O are called as products. NaCl and H2O are called as products. Okay, so like this, reactants and products, when they are represented in this form, that is called as chemical equation. So reactants are written always on the left hand side, products are written always on the right hand side of this arrow. Okay, this arrow is pronounced as gives rise gives rise to. We should pronounce it as gives rise to. So how we should read this equation? I am reading now. Let us see. NaOH plus HCl gives rise to NaCl plus H2O. So in that way we should read now. Okay. So this is the brief introduction about a chemical equation. Yes. In your 10th class textbook, they are given some of the chemical equations activities. So let us do that activities practically and let us will see. So here they are given in the first activity. They are given 3 activities. So in the first activity, what they have taken, let us see. In the first activity, they are taking 1 gram of calcium quicklime. Quicklime is also known as calcium oxide. So quicklime chemical name is calcium oxide. Common name is quicklime. Chemical name is calcium oxide. So what is the formula for quicklime? Formula is CaO. CaO means the calcium oxide. Ca calcium. O means oxide. Calcium oxide. Okay. When it is mixed with 10 ml of water. I am mixing with 10 ml of water. So after mixing, what is the product? Let us observe by doing this activity. See here, I am taking a test tube. I am taking a test tube. Okay, and here in this is your chemical calcium oxide. A little quantity of quicklime I am taking the test tube. You take in the beaker also. No? We can take in beaker also. So we will do in the beaker only. See here, in the beaker I am taking a small 1 gram of calcium oxide. So to this calcium oxide I am adding water. See, when I am adding water, you can see there is a white color liquid is formed. Okay. So here what I am doing, we touch the beaker of this bottom of this beaker. When you are touching, I am feeling somewhat hot. Okay, so that is it is becoming warm. So what is that reaction? It is forming after mixing that quicklime CaO with water. What it is formed? Let us see. So see here, CaO on reacting with water. What is water formula? H2O. Okay, when they are reacting, they are forming calcium hydroxide. So it is forming calcium hydroxide. So this white color liquid is nothing but your calcium hydroxide. Okay. So it is also called as slaked lime. Okay. So it is called as slaked lime. Slaked lime. Common name or chemical name is calcium. OH is hydroxide. So calcium hydroxide. Calcium hydroxide. Okay, so what is CaO? Quicklime. Okay. CaO is quicklime, common name. What is chemical name? Chemical name is calcium oxide or calcium oxide. So whenever calcium oxide reacts with water, it is forming calcium hydroxide. Along with that, small amount of heat energy is released. Okay, so because of this heat only, when you are touching this beaker, we are getting hot. Okay. So that is, it is becoming hot because of the reaction of this calcium hydroxide. Okay, because it is forming calcium hydroxide, it is forming heat. It is releasing heat. So whenever you see heat is released in such reactions, means such type of reactions we are calling them as exothermic reactions. Now we are calling them as exothermic reactions. RXL means reaction. Now you can get full form also. I will write full form also. See here. Exothermic reaction. So what is the exothermic reaction? In a reaction, this total chemical equation, we can also call this reaction. In a reaction, if heat is released, means such type of reaction we are calling as exothermic reaction. Okay. So if heat is released in a reaction, if heat is released in a reaction, then it is called exothermic reaction. Okay, no? So your first activity is nothing but your exothermic reaction. To indicate that exothermic reaction unit, you are doing this activity. Okay? Yes. Now let us see second activity. So let us see the second activity, activity 2. So in the second activity, there are two chemicals. So that is sodium sulfate you have to take. Sodium sulfate, and we should also take barium chloride. Barium chloride. So how much we will take? Let us think that I am taking 1 gram of sodium sulfate and I am taking 1 gram of barium chloride. I am taking 1 gram of sodium sulfate and I am mixing with 10 ml of water. 10 ml of water in 1 liter mix. Same way, we take 1 gram of barium chloride and mix with 10 ml of water. Mix with 10 ml of water. Okay, what will happen we will see now practically. Okay. Yes. Yes. Here, this instrument apparatus is called as conical flask. So in this conical flask, what I am taking? See here. You can clearly see here sodium sulfate. Okay. So I am taking sodium sulfate in this conical flask. 1 gram. 1 gram is 1 spatula. This one we are calling it as spatula. See here. This is called as spatula. I am taking 1 gram of 1 spatula. 1 spoon means it will be 1 gram. So 1 gram I am taking this conical flask and I am taking 10 ml of water. 10 ml means little quantity. Shakes. So you prepare this solution. Okay. Whenever salt is mixed with water means it is called as solution. Okay. Yes. Then what next we have to take 1 gram of barium chloride. See here. I am taking here. See here barium chloride. So I am taking 1 gram of barium chloride. 1 gram of barium chloride. Again you mix with water. Okay. So these two are mixed. So this is your barium chloride solution. You mix properly till all the salt is dissolved. Okay. So what is this solution? Sodium sulfate solution. Okay. And what is this solution? Barium chloride solution. Now you mix this total two solutions in one beaker. So I am mixing this sodium sulfate in this. When I am mixing, see here. Before mixing, they are somewhat clear solutions. Now after mixing, what will happen? Let us see. Yes, before mixing they were somewhat colorless, but after mixing you can clearly see here milky white solution has been formed. So it is not a solution, it is a PPT. PPT means same like a curd, not completely liquid, not completely solid. So we can see a milky white PPT has been formed. What is this milky white PPT? Let us see on the board. Okay, see here. What are the chemicals? See here what we have taken. Sodium sulfate. Sodium sulfate formula is what? Na2SO4 plus we have mixed sodium sulfate with what? Barium chloride. Barium chloride formula is what? BaCl2. Okay, so when these two are mixed, it will give rise to, you exchange the sulfate to here and chloride to here. So it will become NaCl to NaCl plus BaSO4. Okay, so BaSO4 is a PPT. This downward arrow is indicating as PPT. So it is your milky white PPT. Milky white PPT and PPT. So this milky white PPT, whatever you are getting here, is nothing but your barium sulfate. Okay, now so that is barium sulfate. BaSO4 means barium sulfate. Okay, understood? So this is the second activity. So what is this Na2SO4? Sodium sulfate, you can write here. barium chloride. Okay. When these two are reacting, we are taking raised to barium sulfate plus NaCl. What is here formed in between? Plus, what is this NaCl? Sodium chloride. Cl is your chloride plus BaSO4 is barium sulfate. So let's get carried in the chemical equation. So this is our second activity. Okay, ma? Now let us see the third activity. Let us see the third activity. So what is the third activity? So they are taking a few pieces of zinc, few zinc granules they are taken and they have added 1 ml of or 10 ml of HCl acid to this zinc granules. What will happen? We'll let us see. Okay, ma? See here. I am taking here a test tube I am taking. Ma? So this tube is called as test tube, and this handle is called as holder. So I am taking the test tube with the help of this holder. So in this test tube, what I am taking here? Zinc granules. In your textbook they are given in the Volcker flask also. You can do in the Volcker flask also. But the burning matchstick indication is there. So in this it is not getting properly. So in test tube also we can do. Here we can do the practical burning matchstick here. Okay, it will be very clear, you know. So for that sake I am taking the test tube. So in the test tube I am taking zinc granules. See here, zinc granules. Zn is zinc. See here, you can see zinc dust powder. You can take granules or metal powder also. So let us take zinc granules. See here, I am taking zinc granules like this. For the zinc, what we should add? 10 ml of HCl acid. So here I have taken in this test tube HCl acid now, hydrochloric acid. Now I am mixing this HCl acid to this zinc metal. So when I am mixing, try to observe carefully what is happening at the bottom of this. See here, some bubbles have been evolved. See here, some bubbles you can see here. So I am closing the mouth of the test tube because these bubbles are indicating that some gas has been evolved in this test tube. Okay, so I want to test what is that gas. For testing that gas, let us introduce the burning matchstick into this test tube. So to escape hold that gas, I am closing the mouth of the test tube with the finger one, because if it is escaping means you can't test what gas it is for. So let us do. So Lata, come here. See here, Lata is introducing burning matchstick in this test tube. See here, when you are introducing, what it is happening? See, you can see some white fumes are formed in the test tube. So that means these white fumes, that burning matchstick has been put off now, and some sound also we heard, pop sound. Okay, so because this burning matchstick is putting off the pop sound, we are that it is indicating that it is hydrogen gas now. Okay, so if a burning matchstick is putting off with a pop sound when it is introduced into the test tube or Volcker flask, means that is the hydrogen gas. So that is a test for hydrogen gas. So let us see what is the reaction here. Zinc granules, when it is reacting with what? HCl acid. HCl, it is forming ZnCl2 plus H2, hydrogen. It is a gas, yes, it is indicated by upward arrow. Okay, so here it is indicated by upward arrow. So what is this? Zn is zinc. HCl, hydrochloric acid. Hydrochloric acid gives rise to. Okay, then ZnCl2 is called as zinc chloride. Zinc chloride plus H2 means hydrogen. Hydrogen. Upward arrow indicates that gas. Okay, so this is our activity. Okay, see here, 2 chloric and 2 So here I am writing 2 HCl, 2 hydrogens balanced, 2 chlorines balanced. So this is our activity. So thank you, all of you understood? Okay.